So yeah, I'm going to be talking today about my work on tracing and shaping paths in design space. What exactly that means we'll get into in a second. Before that, I guess just a little bit of brief intro. I am currently running the storytelling lab at Midjourney. That's actually kind of winding down at the moment. So we're kind of like at the end of 2025, kind of like pivoting into more product-oriented work. Right now, that's like 6 full-time researchers and in particular 1 visiting researcher front row here. And soon I'm actually going to be an assistant professor of design tech at Cornell Tech in New York City, officially starting July 2026, after possibly a stint at Berkeley as a visiting researcher of some sort. We'll see what that entails. My research broadly looks at AI-based creativity support tools, or CSTs, which is to say tools that include some kind of algorithmic support for human creative practices or processes or workflows or something of that nature. And as a result, I tend to be active on both the artificial intelligence and the HCI sides of CST research. So both building novel models and algorithms and processes that can somehow play a role in creativity, but also building novel user interfaces and design systems around those that enable people to make use of them in their own creative technology sort of like practice. My PhD was actually in computational media at UC Santa Cruz, and that was kind of like a games-focused department. So my graduate work focused a lot on technical games research. That included AI-based tools for game developers, helping people kind of like sketch out game design ideas rapidly, interactive narrative AI, so maybe making it possible to generate like little character simulations and sift stories out of those to sort of surface to people, like the narratives that are emerging from these interactions. And more generally on playful forms of creativity. So making creativity more approachable and accessible to people who are not necessarily used to thinking of themselves as creatives or artists. And in general, all of this tends to happen in the domains of storytelling and game design and poetry mostly. These have been like sort of the main areas of my past work. And each of these continues to be sort of a theme in my work today. So this talk is going to be focused on my very recent and near-term future work. The broad focus of that has been understanding user behavior in creativity support tools as they sort of do their creative work by analyzing people's trajectories through design space. The idea here is that we can kind of model the spaces of artifacts, whether that's games or images or stories or whatever it is that people are making in a creative practice, as a gigantic sort of like space of possible configurations that they could be assembling. And looking at their paths through that space as they use a tool to navigate to kind of make sense of the points of divergence and convergence and the moments of inspiration and blockage and these different kind of phenomena or dynamics that tend to characterize these creative practices. And I have 2 main questions that I've been sort of pushing towards answering lately. One of them is, can we develop these empirical and scalable and non-reductionist approaches to evaluating computer-supported creative processes? Empirical is to say grounded in the data, looking at what people are actually doing and sort of like using that concrete evidence of their activity to make sense of the way that the creative process is unfolding. Scalable is to say we can deploy these at large scale, i.e. to look at thousands or hundreds of thousands or millions or whatever traces or records of creative activity in especially these digital support tools that are now being very widely deployed and used in different domains. And non-reductionist is to say that I'm really hoping we can avoid quantifying creativity in like this naive sense of looking at 2 different artifacts and saying this one's more creative or this one's better because it has some sort of like flat number about it. And more looking at different sort of characterizations, which might be partially quantitative, partially qualitative, that can be used to make sense of maybe this particular creative process is more divergent or more convergent. Maybe this is better at orchestrating between different users in a certain way. Maybe this one leads to different kinds of ideas or different levels of expressive communication happening to users, et cetera, all trying to sort of make sense of the creative process at scale, but in a way that we're not just sort of trying to put a number on it and say that this is more creative than this. My second question, sort of building onto this initial work, is can we use these methods then, once we've got these sort of techniques or algorithms or whatever that can be used to make sense of these creative activity traces, to build computational systems that then usefully and proactively intervene in the human creative process. I think proactive here is kind of a fraught term in some ways. I think when we think of proactivity in the creative process, we often think of Clippy. There's like a little guy in the corner of the screen that pops up and is like, it looks like you're trying to write a letter, can I help? And so we're all sort of haunted by the specter of Clippy. However, I do think there's useful things that can still be done, especially if you're able to kind of gauge where in the creative process people are and whether they're in kind of a converging or a diverging mode right now, whether they're getting lost or what sort of like trying to find a new idea, et cetera. That can be sort of used to steer people or support their navigation of these creative spaces more effectively. So getting into the material of what this is. First question is, again, how can we characterize the trajectory of these co-creative interactions at scale? When we look at people's movements through these creative spaces, what do we sort of see emerging and how do we even begin to make sense of these very open-ended behaviors? In this first section here, I'm going to talk about some work I did during my PhD, and this is on mixed initiative creative interfaces, where the assumption is that there's a generative model under the hood, maybe learned from training data or maybe defined by rules, that's capable of being operated in an unguided or an autonomous mode. That is to say, we've got some sort of like computational process that can generate artifacts. These might be games, these might be like sort of weird little critter images like we've got on the right-hand side, but either way, the system is capable of sort of on its own producing a bunch of different creative artifacts, or artifacts that a human observer might call creative. And then there's a user interface on top of that that you can sort of use to navigate this space of artifacts and pick out or select the ones that you think are most interesting. On the left-hand side here, we've got an example of a system I did during my PhD called Germinate. This is a mixed initiative casual creator for what we called rhetorical game design. The idea is that on the left-hand side, you've got these little cards where you can specify that my game includes an entity called a friend, and it's got this little sort of emoji for an image of it. There's certain resources like depression and confidence that might go up and down. These are sort of quantitative or numeric. And then you sort of specify how the player should feel about one of these. So maybe like confidence should not make the player feel bad when you get more of it. Then you kind of hit the generate button. You get a bunch of these little sort of example games that are playable. And you can sort of navigate through these and sort of pick out the rules that have been generated to kind of instantiate your intent as a concrete set of game rules, and grab the ones you think are most interesting and kind of add them back to your intent and kind of iteratively revise. And what's actually going on behind the scenes here is there's an answer set program, sort of like constraint model, that's being used to generate game designs that kind of match your creative intent in some way. And the tool is exposing this visual language for manipulating these constraints, kind of sculpt down the space of all possible games that could emerge from combining certain kinds of mechanics or rules to just those that are somehow aligned with what you're trying to say or get across. So this is an example of a generative model with a mixed initiative creative interface around it, where you would be sort of like using this constraint model sort of to sort of like explore the space of possible game designs. On the other hand, we have things like Meet the Ganimals. And this is a system that Ziv Epstein et al. Did in 2020. And this is kind of a GAN-based system for coming up with like weird little critter images, basically. It's kind of a derivative of Artbreeder, which was this original GAN-based system for like hybridizing lots of images to get out interesting new ones. And the idea here is that there's kind of a social collective sort of people who are using this GAN-based model and using some of these initial creatures to kind of hybridize them and breed them together to come up with images that are somehow, 45% puppy and 50% goldfish or something like that. And you end up with critters that look kind of like this, and the most interesting ones kind of bubble up from the latent space that this generative model has learned, get selected by the users, and sort of reproduced or like bred over and over again until they get to more prominence in this sort of like overall ecosystem of images. And so in both of these cases, regardless of like how the actual generativity is implemented, there's a generative model under the hood, and the big space that it kind of implies of creative artifacts is what the users are navigating through the UI. Now, importantly, in these kinds of systems, creating an artifact is basically equal to discovering it within a very large possibility space. There's lots of different images that you could assemble that have little plausible critters in them. There's lots of different games you could assemble from this like large collection of possible rules and mechanics. And so what the system is really trying to do is help people sort of steer through or navigate the space to find the ones that are most of interest to them. And those are kind of your creations as a user. And when we're trying to make sense of generative models that are operated without a user interface on top, in game design, for instance, we often use a technique that's called expressive range analysis, or ERA. The idea here, this is kind of from the original ERA paper, I think this is like 2010 or something, and it was about analyzing game levels that have been generated for kind of like a Mario-style platformer game. The idea here is you can kind of generate lots and lots of levels, basically every level that the generator is possibly able to produce from its total expressive range, and characterize each of them quantitatively according to these two dimensions of linearity and leniency. Linearity is kind of just the straightness of the path from the beginning to the end of the level. Leniency is how often a simulated playtester succeeds or fails at completing the level. And then kind of plot a heat map of all of the levels that this level generator can produce, kind of indicating where on these two axes they tend to fall, based on this sort of computational or quantitative characterization of these two aesthetic attributes or properties of a game level. And so you see here there's kind of like a center of mass around here, where like the generator is more likely to produce levels that are of, like 0.21 linearity or something like that, and like, 0.25 leniency. And there's some outliers that kind of live at the far edges of this range. There's some that you can barely see down here. And in general, you kind of pan around this space to sort of visualize the fingerprint of all the levels or all the artifacts that this generator is capable of producing. And then you can have lots of different lots of different measure pairs. Besides just linearity and leniency, you could invent new ones and use these two-dimensional slices to kind of make sense of the overall distribution of outputs that this particular generative model could, in theory, yield. However, if you're trying to use this approach to make sense of co-creative interactions specifically, where there's a user and a user interface on top of this generative model, then there's a lot of kinds of problems that expressive range analysis alone can't necessarily help you characterize. One of these is that the UI might limit access to some parts of this expressive range. So for instance, if there's like stuff down here that is maybe of interest to certain creators, people who are trying to design certain kinds of platformer levels, but the user interface is for whatever reason restricting you from accessing these levels or being able to generate these, then that might sort of be a problem from the user's perspective. The expressive range might be too wide or too narrow to help users find or make the kinds of artifacts they're looking for. It's possible that there's too many sort of like garbage levels or junk levels from the user's perspective that are in this outlier space, and so they feel overwhelmed or like they're having difficulty sifting through all the different sort of possible configurations to find just the ones that are of particular, interest to them. It's possible that users might be biased towards typical artifacts from this generative model's perspective. For instance, if there's like a really heavy center of mass over here, and almost every level that you're able to generate is very similar to all the others in terms of the aesthetic dimensions you care about, then users might not be able to sort of steer towards parts of the theoretically extant level space that would be of interest to them. And similarly, users might be pushed to converge too soon on a narrow corner of the expressive range by the user interface. Maybe if it's kind of like a recommender system-based UI, then you're sort of like saying yes or no, thumbs up, thumbs down to a bunch of examples you've been shown, and then you get kind of like locked into a particular corner without the system being able to like sort of show you things from further outside of your preferences that you've expressed so far. Or simultaneously, you might have this other problem of not being able to converge when you want to. Maybe the user interface just shows you like random draws from this level distribution, and so you can't actually like sort of force it to converge when you're looking for a particular kind of thing. And all of these problems are kind of hard to discover through conventional user study methods alone, because users are not good at reporting or understanding what they're not being shown or what could be happening that isn't. And so as a result, when they're trying to navigate these rather opaque spaces of lots and lots of possible artifacts, especially when there's a lot of open-ended things that could be included in this range, then it's not clear to users when they're actually having trouble with the tool itself, when they're having trouble with the user interface part of it specifically, when they're having trouble with the underlying generative model not capturing what they're interested in, or some other aspect of the interaction just not sort of like working for them. And so it's really hard to kind of get at this stuff without having some better way to characterize the relationship between the user interface and the user and the model on the other side. And so what I did during the end of my PhD was expressive range coverage analysis. The idea here is that we first do the same thing that we've been doing for ERA. We take a underlying generative model with some sort of tool that we're wrapping around it and construct a bunch of histograms or heat maps of lots of artifacts produced by the generator itself in this unguided mode. Then we ask a small number of users to actually sort of use this tool that we've built to create several artifacts each using a mixed initiative interface on top of the generative model. And then we kind of visually overlay these on the expressive range histograms as a scatterplot layer to be able to look at the distribution of user-created artifacts in relation to the underlying space of things that could be produced by this tool in theory. And I'll show an example of that in a second. What we actually did was with this poetry tool called Redactionist that we built. This is an erasure poetry tool. So you kind of take some input text, drop it into this editor, and it automatically erases or blacks out the vast majority of words in this text. And there's kind of an NLP constraint-based model that's helping you sort of pick out words that might be of interest to include in your poem. And you can kind of hover over these purple or pinkish words to either like include them or disinclude them from the final poem. So what you're doing is you're kind of taking an input text and interactively editing it down to a handful of words that are left behind. And the words that are left behind constitute the poem that you've created. And so what we do is kind of give this tool to a bunch of different people with a fixed input text, have them all edit it down to produce a sequence of poems, I think 10 in this case. And then we have these different users' individual poems they've created from this input source, sort of overlaid on top of the distribution of all poems that this generator could produce given that same input. So immediately we start to see that in terms of these two aesthetic characteristics, basically the average word position of like where in the source text these words are being drawn from for the user, and then the distance between the first and last words, so like how much of the source text they cover in terms of their extraction. We see that different users, represented here by different colors, are actually preferring to sample from or draw from different parts of the expressive range. We see that, for instance, the user who's making these poems noted as red dots here is very tightly clustered in one corner of this expressive range. And they have sort of a home region they keep coming back to, where they sample a lot of different poems from the same sort of general position within the source text. Similarly, for the blue user down here, they're more of an outlier in some ways, like relative to the baseline distribution. The green user is only producing things that kind of fall in the south half of this graph mostly. The orange user's got kind of this like main sequence sort of thing going on up here. And each of these users is very clearly like sort of preferring different words or different aspects of the source text to kind of include in the poems that they're creating. In addition, when we start looking at whether users make typical artifacts, there are certain aesthetic characteristics where it becomes very clear that the generator has a sort of a preference or a bias, and the users are like actively pushing away from it. In this case in particular, we see that certain words are very likely to be included in poems by the generator itself, and certain pairs of words especially tend to co-occur very strongly. But users are actually mostly not covering this sort of center of mass that the generator is yielding given this initial input. They tend to be producing poems that are very weird or divergent from the generator's perspective, and in some cases even show up in corners where it's like unclear that there's any poems that are even possible. So it seems like some users at least are actively pushing away from the center of mass or trying to differentiate their poems from what the generator produces by default. We also see when we look at sequences of artifacts that one person has made, that there are certain characteristic trajectories or patterns of movement that they're engaging in. So in this case, we kind of use this rather rough encoding of color to denote artifact creation order, but we can see that the initial poems that this person is creating are kind of over here, pretty close to the center of mass for these particular aesthetic characteristics. And then they kind of start moving more and more down in this direction. We see a poem over here. We see one that's kind of a weird outlier where they pushed it a little further. They come back to where they started and then start to seem like they're behaving very intentfully and moving more and more down towards this weird outlier corner. And then they do have like 1, 2, 3, 4, 5 or something like that are all kind of pushing towards this sort of exceptional corner of the space. So the user seems to develop a more intent-driven or more convergent behavior over time, where they're like pushing towards a particular aspect of the aesthetics. When we look at these comparatively, we can see that there's recurring patterns across a lot of different users. Here we see them tending to zigzag between their home region and further flung corners of the expressive range. In particular, you can see these tight little clusters here where like these are not all created at the same time or like one after another. They do like their first poem and their second poem and their fourth poem and their sixth poem and their 10th poem are all drawn from this same relatively narrow window. And then everything else is kind of an outlier where they're pushing out further. And similarly over here, there's a relatively tight cluster towards the end where they're like mostly sampling from this sort of corner of the range, but they've taken a while to zigzag around before getting there. And some users in particular seem to be deliberately probing the boundaries of this expressive range. This kind of dovetails with this idea of curious users of casual creators that was observed in some earlier work on game design, where some people seem to be playing with these tools predominantly as weird little toys, where they can sort of like try to push it as far as they can in a particular direction and see what happens. In particular, with P4 here, we see that one of the poems this person created is so far off the charts that we actually had to literally change the boundaries of this plot to be able to get it included. We realized that there was one that had gone missing, and we had to like sort of repan to like make sure that this was included in this final visualization. So here, this person was really sort of like pushing as far as they could in this particular aesthetic direction, and a lot of their poems are outliers actually, outliers in different directions even. So like here's one, here's one, here's one, here's one, here's one. They're all kind of like on this weird edge of the possibility space. And of course, you can do this pairwise thing I was talking about where you have lots of different metrics and show all of these metric pairs at once and then kind of use this to jump off into more fine-grained or more detailed analyses depending on what seems to be interesting here. Of course, this is all based on the assumption, again, that creating an artifact is equal to discovering it in this very large possibility space, right? There's kind of an input text, there's a tool that you're using to sort of like navigate it to produce poems, and there's a finite number of poems that could possibly be produced given this kind of natural language constraint system on top of this initial input. And so we can sort of characterize all of these poems in terms of where they fall in that sort of relatively finite space. It's a large space, but it's a finite one. There's like thousands of poems or something like that. However, this becomes very problematic when you actually can't systematically enumerate your possibility space, for instance, because it's just too large. And so with open-ended text input, with open-ended image input, and especially with a lot of things that we're now thinking of as generative AI, I think we start to see these very large compositional spaces of artifacts where you just can't possibly look at every possible artifact the system could in theory generate and then look at the user ones in relation to that. So we kind of need some alternative technique if we want to characterize systems like this one. This is an AI-supported world-building canvas that we built at Midjourney. It's called Patchwork. The idea here is that you're kind of importing images and importing text and getting suggestions from the AI and kind of composing them into these little like sort of comic-y world-building Bible things. So you invent some character concepts, you maybe like sort of tell a little picture story out of these different characters using their faces to kind of like render more panels in a sequence. You ask for like a prop concept, it gives you these danger flowers that are sort of like given as a gift by one of these characters to another, kind of like a court intrigue setting or whatever. And there's some stylistic and character consistency stuff being done to enforce that everything sort of feels coherent to some level. And because people here are creating these boards where there's lots of different text on them, lots and lots of different images, some of these are generated, some of them are imported, some of them are written by hand, it becomes rapidly really, really hard to characterize the full range of things you could possibly do with this tool. And there's so many different things that could happen here that you really can't apply this sense of like enumerating the possibility space of, you know, like millions, billions, this very, very, very large numbers very rapidly of possible patchwork canvases. And so to make sense of the interactions in these kinds of spaces, you need some alternative technique. One thing that would be kind of neat is if we could characterize this interaction via what we're calling linkography. This is a technique from the 1990s that was originally introduced to study architects, and specifically architects kind of like sitting around in a group environment designing buildings together. So they've got kind of like maybe a canvas in front of them, and they're all kind of like, sketching on the canvas and talking about what they want to do and sort of like improving this building design very gradually as they look at the site and they look at the constraints. And what happens with these linkography processes is you've got a human annotator who's kind of sitting there in the room with these architects, noting down everything they say and do. And then afterwards, you kind of look at the transcript and chunk into what we're called design moves. So design moves here are kind of notated on this timeline from 0 to 12. So this is a design move, this is another one, this is another one, this is another one, et cetera. And we don't really sort of note the temporality between them so much. We just kind of know that this one happened after this one or followed this one. And then we draw links below the ones that seem to be related or that seem to be progressing or building on the previous moves in the sequence. So here, the first move might be something like, I think we need to have a shed in this design. And then someone might be like, the shed should have a door that's like this. And someone might be, the door needs to have like some sort of like, hinge system that does this kind of thing. And then someone else talks about the shed a little bit further. Number 4 here is an orphan move, or what's basically an ignored digression. So this might be someone decides that like, guys, what if we need to make sure that the water feature has like a really prominent, sort of placement in the design? And then everyone kind of doesn't go back to that or doesn't think about that again. Then moves 5 through 9 here constitute what's called a chunk of moves, where there's still some degree of interrelation between them. You see here that this is kind of like the inciting incident, and people are kind of riffing on it or responding to it loosely, but they're not always responding to it directly. So like move 6 here might be a direct response to move 5, but then move 8 responds to like move 6 more than to move 5 specifically. And then at the end, we've got kind of a sawtooth pattern from 9 to 12 of sort of a bouncing back and forth between two ideas that are kind of like rapidly ping-ponging sort of into one another. So this might be like two people are kind of like going back and forth on one particular feature of the design without sort of going back to the earlier constraints or trying to ground it in the earlier discussion at all. And so when you sort of create these linkographs, you can start to see these high-level shapes of interactions between multiple different systems or multiple different users in a co-creative scenario, and maybe even be able to make sense of like where divergence and convergence is happening. Because you can see that these moves are like sort of leading to other moves and sort of like causing lots of people to ideate on a particular topic or a particular focus. And this is kind of like a closing down move where it like integrates maybe some things that have been said before, but then like no one sort of goes back and talks about that topic further. However, this is typically done by hand, and therefore it's basically impossible to apply at scale. There have been a number of papers in HCI that have attempted to apply linkography to the analysis of, for instance, like mixed initiative prompting and like sort of text-to-image prompting and those kinds of things. And for the most part, these papers have stopped at the scale of like dozens of linkographs. The problem is that you've usually got like, a few undergrads who are doing all the coding for you, and they're kind of coming in and like noting down what all these architects are saying, and they have to like sort of each in parallel transcribe the same session, and then chunk it into moves, and then check for agreement between them, and sort of resolve the discrepancies. Then they all draw the links, and the links might not agree, and you end up with this really complicated sort of like thorny process of strong human annotation that's very focused on the details of the situation, but also that is very, very costly to run if you're dealing with very messy data at a very large scale. And so we haven't really been able to apply this kind of technique to the kinds of large-scale interaction logs that are produced by creativity support tools like Patchwork and the other ones that we've been studying. And so what we were trying to introduce when we started sort of analyzing the Patchwork data was this idea of fuzzy linkography, where we can sort of automatically generate very imperfect or fuzzy linkographs using the automatically captured trace data from these digital creativity support tools, where we're already logging everything that happens, every user action, as they sort of develop a canvas. But then we're able to kind of automatically analyze semantic similarity between these moves using an embedding model or some other sort of model of semantic relatedness. And so we can see here kind of me just doing this with a string of text entries. This is kind of me just doing sort of like open-ended ideation really fast. I say things like, hello, hello world, dog, cat, zebra, horse, hello horse world, hello kitty, stream of consciousness, kitty cat, not much money in the kitty, piggy bank, riverbank, stream, cat video. I come up at the end with a Hello Kitty TV show. And this is so clearly like the move that unifies everything into one coherent idea. I was so proud of myself that I was like, we're done, this is it. And so you can see the link patterns here being inferred by this embedding model as we sort of look at the semantic similarity of these text strings. At the beginning, we got hello as this kind of inciting incident that brings in the theme of greetings. Dog kind of brings in the idea of animals and is not connected directly to the greetings theme. Cat is very important in that it sort of like leads to the like sort of later ideas of cats being integrated. Hello Kitty is kind of the first move that integrates the greetings and the animals. Kitty cat is sort of, we bring in the kitty idea, specifically, sort of the rephrase. And then there's this interesting development from like, gradually the idea of money or the bank up to the idea of streams through that to videos. And then finally we get the TV show thing at the end. And so you can see these sort of linked strengths that are somewhat uncertain, because this is sort of like a fuzzy model of semantic similarity, being drawn as different levels of opacity or strength below. But then also that the overall structure of this interaction still becomes pretty clear from the style of visualization, where you can sort of see the way that these design moves build on one another and relate back to one another over the course of this like temporally unfolding creative process. And so, if we can just use this process and apply it to all of the creative activity traces that we collect from a particular digital CST, then we might be able to start making sense of these interactions at much larger scale than we were able to before, or maybe at least use these as like an abstractive summary that we can use for jumping off into like more granular analysis on graphs that look really weird or interesting for whatever reason. And so in practice, that is what we did. We collected 6,424 image prompt sequences from Patchwork users over this 2-week period where we just launched it at the end of 2024. And basically looked at all of these through the lens of fuzzy linkography. What we see immediately is that there's these recurring patterns in these image prompting traces. We're specifically looking at the sequences of image prompts they're submitting here, by the way, to generate images in these canvases. You could probably do this on a larger scale if you tried to include like the text edits and all these other sort of like, behaviors as well. But for the purposes of this study, we tried to like zoom in as much as possible on like a relatively easy to make sense of type of data. And so here we've got these refinement web patterns where a user is making multiple incremental modifications to a single prompt in a row. You can think of this maybe as a series of retakes or updates to a prompt converging on a particular goal image that they're trying to get out. And at the beginning, we can see this kind of a refinement web pattern here where the user does almost the exact same prompt twice in a row. Then they change that slightly, but it's still sort of the same main idea. Then they do a retake of that second revised prompt, and then they kind of stop prompting on this theme for a moment. They come over to some other sort of concept, try that twice, and then there's sort of like an integration of that into a new prompt at the end here. And so this is kind of a refinement web where you can sort of see the user updating or changing their idea a few different times as they update or revise their prompt to more reflect what they want. You've got another one of these right here. I think this is actually just the same prompt being run like 4 times in a row, basically, kind of like rolling the dice to see what you get out. And then another one of these towards the end. And you see these kinds of very basic refinement webs in lots of different sort of image prompting trace sequences. You can also see more complicated or long-term patterns. For instance, this is kind of a curiosity zigzag pattern where the user is alternating back and forth between developing a central or main theme and these kind of digressions where they explore other themes that are not super related. In the initial start here, you can sort of see that like, oh, here's an idea that's kind of like the same thing with like a slight modification to it. Then you see an unrelated idea where they try it twice again with like very little modification between these 2 different attempts. And then these ideas both get woven back in later on, as in they sort of like go back to these themes they were sort of like earlier trying out, but they don't really integrate them all that much. And here you can see that there's kind of a refinement web pattern where they try the same prompt a few times in a row. They even go back to that later on and retry a very similar prompt twice later on. But then there's also this chunk of sort of related to itself stuff in the middle that doesn't really connect to almost anything else in this graph. And there's a lot of these orphan moves or digressions where it's just like a one-off prompt that never gets revisited or reintegrated with the rest of the session. And so you can sort of see the bouncing back and forth between like, I'll try something that seems relevant to my main idea, then I try some unrelated stuff, then I go back to my main idea, then, et cetera, sort of like zigzagging back and forth in the way that we saw in those previous expressive range coverage graphs as well. We can also see things like a converging zigzag. This is kind of a hybrid pattern where disparate explorations are both visible and then being gradually integrated into a single theme. The idea in this particular linker graph, which I find particularly charismatic, is that the user actually comes up with first 2 different subjects or characters that they're trying to get out. One of them is kind of a cute old man character, and one of them is a man with the head of a tick, sort of like the bug, the insect. And then you can sort of see that those 2 different subjects are then integrated in this really elaborate refinement web here. There's lots and lots of retakes. They're getting much more similar to one another over time as the user sort of like refines their prompting language. And then at the end, they kind of arrive at the final hybrid subject image and kind of cut off. This vertical dotted line indicates they kind of like broke the session here and like stepped away for at least 30 minutes from the keyboard. So they kind of were satisfied with this sort of like hybrid tick image, and that's their main character now. That's kind of the guy they're telling the story about. In parallel, even in this very beginning, they were trying out some different visual style ideas. You can see here and here and here some prompts that are more aimed at getting like some different ideas of like what the images might be stylized as or rendered as without really having a particular subject specified. And then in the second half of this prompting, they start integrating those ideas with their hybrid subject character in this first refinement web, and it almost works. They sort of get to an image here that's like a pretty convergent prompt with the previous ones. But they don't seem to quite be satisfied with it. And you can see that there's like this sort of relatively weak link here where they do one more retry that's much more sort of like zoomed out, and then kind of give up for a while. They don't actually sort of like this final image they've gotten out. And then they come back a little bit later and they do one more refinement web, and this time they seem to like actually hit on the idea, and they get out their final hybrid image that has the character that they created rendered in the style that they were trying to visualize. And so you can actually see the structure of this developing very strongly over the course of this particular linker graph. More generally, with this temporality stuff, you can see that some users tend to prompt in very clearly temporally divided sessions. So here, there's a lot of very related to itself stuff in the beginning of this graph, another related to itself chunk here, but a lot of orphan moves, and almost every one of these vertical breaks indicates like a total break in subject matter. This user is not really like retrying the same prompts after they've like sort of walked away from the keyboard. They come back and they try something else instead. And some users, in sharp contrast to that, develop these very long-running projects that kind of persist across these temporal breaks from prompting. So here you can count this like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 temporal breaks that they did. But this is all one giant world that they're building out. And so they're creating images of, it's actually kind of like an avatar-themed fantasy world, where like they create different images of like certain characters they're really interested in as these refinement webs. This one I think is like the leader of a particular faction. This is kind of like a village or a hut or something like they were trying to get out. And you can see these like recurrent refinement web patterns of like, this is the user getting out the definitive image of a different entity, like a character or a person or a clan or whatever, from this story world they're building. And so the interesting differences in temporal behavior here are really visible, I think, when you look at these link structures. Okay, so looking at these linker graphs is really cool. You can learn a lot from them, I think, in terms of like how users are using your tools. But what if you could start using this data to also start building more proactive creative tools? Like for instance, what if we see that someone's getting really locked into a particular corner of the space and maybe they're getting frustrated and like not really having a good time and they might be likely to bounce at this point? Or what if their behavior patterns tend to indicate that they're like obsessed with one particular theme and they just want to see more and more of that image? Well, if we start looking at this, we can start doing things like clustering to start to revealing these designer archetypes. This is a very naive attempt at clustering. This is kind of the first pass thing that came to our minds, which was just a k-means thing with k equals 5. But here we already start to see that these 5 different clusters are sort of different designer archetypes. They're different usage patterns or usage styles of this tool. At the top level here, we can see that these are kind of long-running users. They have like lots and lots of different image prompts. And there's a degree of going back and forth between different ideas. So there's like a refinement web over here, a refinement web over here in this one, some long-range ideas that eventually get brought back, but in like a weaker form or a refined form. And there's like, in general, a lot of development of ideas in these kinds of linker graphs. They're kind of like mixed in their temporality. These clusters 2 and 3 both tend to be of shorter interaction sequences. And we see that this one in particular has a lot of like, sort of like mid-range links. Whereas this one has more long-range links. So like ideas are sort of revisited more often across the longer-term temporality. Here we see the obsessed users. These are the ones that are just like hammering over and over again the same theme or the same concept repeatedly. We got this gigantic refinement web of basically the same thing repeatedly in this one. This one is almost all one big refinement web. So it's like the same idea being brought to the forefront again and again and again. And this is not quite the exact same prompt every time, but the links are so strong that you can see that there's like very little semantic modification going on from one to the next of these. And then at the end, we've got this other pattern that's like, I think this actually needs to be teased apart in separate clusters. Probably there's like a few different things going on here. However, we've also done some recent work on the homogenization effects of these creativity support tools, especially ChatGPT, that I think you can start building an even more sophisticated sort of analysis approach around. So with ChatGPT in the oblique strategies deck, we kind of compared these two different approaches to ideation support. The idea here is that we kind of give users these tasks around like improving a product, coming up with like ways to make this teddy bear better, for instance. Or in like a creative writing scenario, like let's say gravity suddenly flips upside down. What are some possible consequences of that? And have the user kind of enter a bunch of different textual expressions of ideas for what might happen in these scenarios. People who are using ChatGPT obviously just had access to this chatbot and could sort of like use it to query for additional responses or additional ideas. The oblique strategies deck, on the other hand, is this deck of cards that were introduced by Brian Eno and Peter Schmidt, these artists in the 1970s, specifically for artistic ideation. And when you pull one of these cards, it's got a weird phrase on it. It says like, make a sudden, destructive, unpredictable action and incorporate, or like, destroy the most important thing. And so when you pull one of these, it's very like sort of unexpected, jarring, surprising, and tries to get you thinking in unusual directions. And so we compared users of each of these to try to see which one which group of users produced more homogeneous or more similar ideas, and found that, of course, as you might expect, ChatGPT users were more homogeneous. They came up with ideas that were more similar to other users' ideas who are also using ChatGPT in terms of the average semantic similarity of these sort of ideas in idea space. What's interesting is that even though ChatGPT wins on other creativity metrics here, including like flexibility, i.e. the number of categories people cover, and fluency, i.e. the number of ideas they generate, and elaboration, i.e. the amount of detail used to express each one, you still see these group-level homogenization effects coming through quite strongly. And so we were kind of curious about why this is and whether it's like a structural feature of using a language model for ideation, whether it comes from the interaction pattern specifically, like what was going on structurally here that caused this effect. And so we started employing what we were calling multi-actor fuzzy linkography for influence analysis between the human and the AI as these sort of like separate actors in this situation. Specifically here, we use color to denote these two different actors' design moves. So these red moves are human moves. This is the human introducing a new idea of their own. The blue ones here are machine moves, where the machine is kind of like suggested an idea as part of a chat response. And we got these out by basically like looking at the ChatGPT transcripts and kind of parsing them out into structured like entries from the human and from the machine. And you can see here that when we visualize the link patterns, we can also see from the color, the purple ones are interactor moves or interactor links. So this is like the machine responding to the human or vice versa. And the red ones are between human moves, the blue ones are between machine moves. So the actors responding to themselves, basically. And from this, you can begin to assess influence dynamics, where like one of them might be more of a leader or one of them might be a follower at different points in this interaction. And you end up sort of seeing this visually emerging in the graphs. And we see a lot of interesting patterns in these. So first thing that sort of immediately jumps out is that AI misfires are very evident in the graph. In this case, we see like a single user idea, and then they prompt ChatGPT for a batch of ideas. This batch is all pretty linked to itself, so these ideas have some relatedness to one another in terms of how they're expressed. And then the user never touches any of those ever again. And even afterwards, ChatGPT doesn't refer back to these ideas either. So this is basically like a total misfire on the machine's part. It generated this list of like 7 or 8 things. Those 7 or 8 things were all bad from the user's perspective, and they all just got discarded immediately. No one ever touched them again. Meanwhile, we see this massive graph of like growing ChatGPT ideation, where the user is like repeatedly reprompting and reprompting and reprompting. And here we see that the user actually is integrating some of those at the end into their own ideas. So this is a total misfire, and this was just like a bad move, and we know that automatically. Like the user should not have had to deal with that. We also see that user ideas, especially early on, are very diverse. This kind of makes sense because we were prompting them to be diverse. We were telling them to come up with as many different possibilities as possible. And the ChatGPT, of course, generates these large batches of ideas all at once. This is kind of unnatural, I think, because in human-human turn-taking, usually I say something and you say something, and I say something and you say something, and there's kind of a nice back and forth. And if one of us said like a sentence and the other one said like a 10-paragraph response, and it wasn't like a formal interview setting, then that would be very surprising and jarring and probably bad. And we do not see that happening with ChatGPT. We see these like really long batches of like ChatGPT kind of takes the wheel and produces like a list of 10 bullet points or whatever. And the user kind of gets overwhelmed by the sheer volume of text that's being produced. We also see that ChatGPT ideas have more semantic relatedness to one another than user ideas do. So the links between these blue ideas are clearly stronger in terms of like the semantic similarity than the links between the user ideas, especially at the very beginning of this session. Here we see like the user came up with a totally orphan move that's like not related to anything. We see a few that are like, oh yeah, like this one very vaguely gets integrated into this last idea at the end, but there's not a lot of like, you know, human to human idea relatedness. And meanwhile, in the middle here, we see like ChatGPT is using very similar language to talk about lots of this like sort of like variations on the same concept, basically. And over the course of the temporal transcript, ChatGPT is going to be more related to one another as the interaction proceeds. So we see these links getting progressively stronger, and there's like, you know, more and more linkage between the batches as we sort of like asked for multiple different, you know, lists of ideas from the machine. And interestingly, this sort of all leads users to eventually switch into what we call a predominantly curationist mode, where they're more focused on filtering and integrating ChatGPT output than on coming up with new interesting sort of like inputs of their own. So here we see like, okay, they've got a few ideas of their own at the beginning. They prompt a whole bunch. They have some more ideas in the middle here. Some of these are kind of modifying or riffing on ChatGPT ideas. One of them is sort of copied quite strongly, maybe even copy-pasted verbatim. But then over here, there's a few that are kind of related to their own ideation, but not as much to what the machine has said. And later on, they say one more thing of their own that's just like a, again, nearly verbatim riff on a ChatGPT idea, ask for one more batch of ChatGPT output, and then kind of at the very end of the session, pick out a few that are the most sort of like interesting or relevant to them. The last two of which are just integrations of themes from multiple different machine-generated outputs. So they're kind of like cherry-picking the best of the ChatGPT output and like refining it down into something that they can call their own. ChatGPT ideas, notably, do not build much on user ideas, and this is happening across a lot of these graphs. The influence ends up sort of going mostly one way, from the machine to the user, and not the other way around. And again, because these dynamics occur across a lot of different ideation sessions under very different usage patterns, with just trying all kinds of clever prompts to get more interesting outputs of the machine, and even at very different levels of overall link density, where some of these things are like much more copy-paste heavy. Some of them involve the user like repeatedly prompting the machine for lots and lots of stuff. Some of them involve much more sparing usage. As we see here, there's like a lot of the users still trying to maintain control by coming up with their own ideas partway through. We still see these overall patterns in each of these graphs, basically. Strengthening link connectivity over time, and the machine being more and more homogeneous in particular, with the user more and more taking a back seat to kind of like integrating or filtering machine output. And when you do quantitative analysis on sort of the aggregate backlink densities, links sort of going from a later idea to to an earlier idea, you can even sort of confirm this quantitatively. So when we look at excluding copy pastes from the human of the machine to the human's output, then the human-human links are rather strong. The machine-machine links are even stronger, so the machine refers back to its own output quite a bit. The human-machine links are pretty strong, and even stronger when you include copy-paste verbatim. And the machine very rarely, like almost half as likely, refers back to the human ideas. And so the machine's not being influenced very much by what the human is putting in. The human's being influenced quite a bit by what the machine is putting out. And I think there's an interesting reason for this, actually. It seems in general that the human is very reluctant to actually articulate into the chat transcript the things that they're saying out loud to us about what's frustrating or bad about the machine output. And so even though they're saying these things out loud that would sort of constrain or change the way the machine might ideate, they either don't have confidence that the machine is going to integrate that meaningfully, or they don't want to do the work of encoding it into the chat, or they feel like they can just sort of keep on mashing the button and get more machine output. And so for any sort of combination of these reasons, they end up mostly not telling the machine what it is they're looking for, and not sort of like putting more of themselves into the interaction as it proceeds. Okay, so I think this has a lot of interesting design implications for co-creative interactions. One of these is that when you look at this graph in terms of the links between the previous ideas, there might be some ideas that are unintegrated or that have not been brought into the overall like sort of ideation pattern particularly strongly yet. So if the machine's going to make proactive moves, it might want to look at doing proactive integrations of ideas that are kind of divergent or out there, that have been kind of ignored or that might be sort of treated as digressions otherwise. Another thing that's interesting here is that periods of high and low creative momentum can probably be gauged by looking at these sort of sequences of interactions and determining whether the user is like trying the same thing over and over again, or trying a lot of different things, kind of casting about for a new idea, or whether they're even like getting stuck maybe and like just mashing the try again button rather than like inputting new ideas of their own. We can start to gauge when the machine doesn't seem to be taking much influence from human moves by looking at the link strengths between the machine and the human moves. And at that point, it might be a good time to start proactively eliciting intent, maybe like asking the user questions to try to get them to say more or express more of what they're thinking, so that the machine doesn't become so totally indexed on its own output and just get more homogeneous over time. And I think it's interesting that all of these strategies kind of work cross-domain as long as you've got a good embedding model of the content that's under edit. So beyond just text, which we were using in this study, there's also now good embedding models for things like audio and game levels. There was a cool one called UI clip for user interfaces that I think some people have probably seen. And so when you start looking at these different creative domains, it seems like there's a lot of relatively rich data that's available from these activity traces that can then maybe start to be integrated into more of like a coherent theory of how design processes tend to unfold temporally under different user interface constraints, maybe, given these sort of embedding-based approaches to analysis. More generally, I think there's this really interesting pattern of linkographic abundance that we started to see coming out of this. Because we have this technique that can run really fast and process lots and lots of traces very quickly, even though they're kind of producing relatively weak or like hard to interpret outputs in some cases, we can still start to casually drop this technique into new domains and kind of probe around for things that might or might not be interesting very easily. And so we actually sort of ran a separate study as part of this paper where we grabbed the Google Scholar titles of each of the authors and some other people that we knew and ran that through the Linkography process and tried to see if anything came out of that. And there were mostly nothing like sort of interesting in the vast majority of those graphs, but we were able to see these different career shapes through people who had sort of unusually shaped careers. One of them was kind of like a wandering postdoc for a long time who like went from one group to another doing like largely unrelated topics, and that was very visible in the graph structure. And one of them was somebody who had like an early career pivot where they were in a lab, then that lab kind of fell apart and they had to like join a different lab, and that's where their main career like sort of graph sort of came together. And so without the ability to kind of like run these analyses very easily, I don't think we ever would have thought to even try that. And even though we didn't learn like that much from doing it, it seems like there is something there to be mined out that might benefit from like, you know, like longer text embeddings or some other approach to analysis that might be interesting to look at in the future. Also, we're starting to build techniques that kind of integrate this with the expressive range coverage analysis that we saw earlier on. This is a project that Jim has been working on called Artographer, where we kind of literalize the idea of semantic space exploration by taking the clip embeddings of a bunch of museum data and kind of spatializing it according to kind of like this, this clustering / like clip-based embedding thing. So we kind of take everything, overlay it on this map, use Voronoi to kind of like find regions or like sort of areas of similar artifacts. In this case, paintings and photographs and other things that have been collected by museums with some textual description of them, and then kind of allow people to navigate this map physically, and even use generation of images to kind of jump around. So if you type in like cat, for instance, it might sort of like zoom you towards like a cluster of cat images where your cat is being generated near the other ones from history. And what we see when we start letting users navigate around these interfaces and collect images that they find interesting is that these trajectories can now be very easily visualized and actually shown to participants during debrief, among other things. I think this is a really promising sort of like probe thing to do in the future. And we see some familiar movement patterns here as well. So in this particular case, we've got a user who starts out over here, starts sort of like panning around the space and navigating through it very interestingly. They find images that are kind of cool and interesting to them, and they kind of collect them, which is what this push pin sort of indicates. They sort of get into this cat cluster, as we talked about, and start collecting like one of these like Lewis Wayne cats probably, and a few other interesting ones. At some point they prompt for ancient mosaic art. They kind of get back on task, I think. They were starting to wander and get lost, and they wanted to like sort of get back to like, what if I'm trying to collect mosaics specifically? And the prompt kind of takes them over to here. They navigate through some past mosaics that are kind of clustered together. They wander a little bit further. They don't find anything they're really interested in this part of the space as much. And then they prompt for a cat again because they want to look at more cats now that they're done. And so we start to see, again, that kind of curiosity zigzaggy behavior, where they're starting to like go back and forth between this theme that is of clear interest to them for an intrinsic reason, and whatever they're supposed to be doing for their task, and like maybe the initial wandering where they're just kind of like probing around the boundaries of the space. We also, really interestingly, see the beginnings of what I would call coverage analysis in clip space, coming up with some interesting findings here, where because this map is physical and spatial and has edges, people try to go to the edges. There is disproportionate collection of images from the outer 15% margin of that map, regardless of what that means semantically, given that it's kind of a relatively naive dimensionality reduction thing that was done to like create that layout. And so there's this really interesting behavior where people are kind of like literally physically pushing the edges of this map in order to try to find the outliers or things that are kind of like outside the median of what the system is able to show them. And so I think there's a lot of really interesting, promising stuff you could start doing here when we start to integrate these methods for analyzing these big, like, you know, spaces of possible artifacts and the ways that people move through them trajectory-wise. Okay. If people want to read more about this, you can check out my publications page. There's a lot on this stuff, especially in the fuzzy Linkography paper specifically. And of course, there's even more coming soon. And I'll take questions now. Thank you.
Okay, I'll start. Oh, was that a question? Okay, anyways, I'll start. Well, thank you for the really great talk. I think the one way you sort of like characterize creativity in this talk is a sort of this process of discovering the design space within AI. I'm curious in building all these like systems, like what do people value? Like you've talked a lot about like where they struggle in this interaction, but like what do people value in this form of like exploratory creative process of like discovering points in the design space? Totally.
I think there's a lot of serendipity that people appreciate about these kinds of interactions. When I talk to artists, especially who are like interested in visual domains, like before AI imagery came around, they often really like the glitchiness or like sort of the strangeness of outputs that the machines can do, and the way that they get sort of outside of what humans might think to create on their own. I have this paper on what I call lost poetry, where I examine this for like creative writing specifically, where the machine is kind of being used to produce stuff that is like lost on it, in the sense that it doesn't understand what it's getting wrong from a human's perspective, but also sometimes productively lost in a way that gets us outside of our preconceptions of what we think poetry like ought to look like. So I think that's a big sort of potential benefit of these machines.
Okay. Is that also why you're seeing like the points towards the outliers of people pushing the boundaries?
I think so, yeah. Okay. As soon as you have a distribution, people want to get like towards the edges of it or find like what's outside of it or whatever. And artists especially, I think, are people who are driven by that like drive to diverge.
Cool, thank you.
Thanks so much for also presenting. This is really interesting. And I guess one of the questions I had going back to the fuzzy Linkography work that you were doing, I was curious if you also saw like, or I was curious, the different user groups that you like surveyed, and if you saw any kind of like sub-trends within these user groups.
So in this particular study, we were mostly looking retroactively at data we'd already collected, and we didn't know much about who these people were. The Patchwork data was from lots and lots of users, like thousands of them, but we didn't really know anything about them besides what they were prompting for, essentially. And in many cases, it seemed like they were mostly doing kind of like world building, Dungeons and Dragons, tabletop campaign stuff, like coming up with ideas for their fantasy novel and that kind of thing. In the ChatGPT ideation study, that was just people recruited from the internet. And so it was pretty much like Mechanical Turk workers and those kinds of people who didn't necessarily have a strong connection to the particular creative task we were asking them to do. And similarly, we had some SCU like undergrads and master's students in there as well, again, who didn't necessarily have like a strong connection to that creative work. So I would actually take the earlier homogenization findings with a little bit of a grain of salt in terms of like it representing the realistic creative process. Because I don't think many people are really sitting down and like just chatting with ChatGPT about the ways they can improve a teddy bear and then like deciding that the best one is the one they're going to actually implement or whatever. I think there's much more in reality of stuff like this this later study we did with the Patchwork data on people kind of going back and forth and like trying to figure out like what images might be of interest to them based on these like, you know, sort of like vague, fuzzy prompts that they're trying out and kind of gradually refining. But yeah, I think these different usage patterns would be very strongly visible if you tried like giving the same tool to maybe people who are more driven by curiosity and driven by exploration desire, rather than those who are like productivity oriented or trying to like make images as fast as possible. So that might be an interesting thing to try in the future, is like give people different framings or like find people from different user groups and like actively see what their patterns of usage look like in different tools.
Yeah. Hi, Max. Thanks for the talk. This is also a question about the Linkography work and like sort of the observation you made that a lot of the AI ideas don't build on past turns, but are like highly coherent amongst each other. So for the AI ideas being coherent, like how much of that do you think is just related to preference tuning, where we just train for like coherence, and like the artifact of that is that it just generates similar things?
Absolutely.
And the shift, is that because people are asking for things? Or I was just curious, what do you think about that?
So what's really interesting is that regardless of how people prompted, we still saw the same thing happening, basically. Some of the users were really clever in terms of like, they'd done a lot of work with ChatGPT in the past. They'd taken a lot of, you know, sort of like human-machine creativity studies probably, and like thought they had techniques for like getting really creative stuff out of the machine, but they didn't. Like, we saw them trying all kinds of like persona prompting and like trying to get it to adopt a certain voice or like sort of constraining it to only use certain words or whatever. And in each of these cases, the overall shift over time looked pretty much the same. So I think part of this is that this was ChatGPT 3.5, which is like very mode collapsed compared to even the more recent like RLHF models. Part of it is RLHF itself does a lot of, you know, stuff to make the model more mode collapsed, and that's kind of what its job is to do, arguably. And part of this is just that people are letting the model kind of drive the interaction more than they probably ought to be, I think. And so like maybe if the model was like less able to generate fully formed outputs, or was only able to generate like things that are suggestive or vague, like the oblique strategies prompts, then that might be better at getting people to keep on putting more of their own thoughts into the process. But I think there's really like a conflation here in the popular conversation of the language model itself has these problems with, like, the fine-tuning process has these problems with, the chat interaction has these problems. And what we see is actually kind of a weird distribution of effects across those, as far as I can tell. I want to do more follow-ups on this to like tease out exactly where each part is happening.
Great talk. I had a question on okay, ChatGPT kind of does its own thing with its own ideas, and like users just kind of ignore that. I'm wondering how much of it is actually like people looking at the output and going, it's time to scrap, I'm going to do the exact opposite, right? It's like they kind of use it as like a, what should I avoid? How often do you see that like interaction pattern, and is it sort of captured in the, I'm wondering, because it's like, when I interact with these models now, I'm like, I know they're maximum likelihood estimators, like it kind of tells me what to avoid.
Yeah.
Is that captured in this like?
We didn't see as much of that in this study. We saw quite a bit of users like implicitly discarding machine ideas, because like when we see the integration patterns here, like they tend to go back to like, oh, here's one or two that I liked from the first batch, and like one or two that I liked from the second batch, and I like merge them together and massage the language to make it fit. And then most of these don't tend to go integrated into like a human submitted idea at the end. So you can arguably say that those ideas that the machine generated are like bad or misfit or something like that. But I didn't see very much where the user was like, the machine's not doing this, so I'm going to do more of it on purpose. And that's a little interesting that I didn't see that, actually. I'm curious like how much that's like the user patterns, like people not having a practice of doing that, and maybe people understand better now that these models are like about likelihood. But I don't know. That's kind of a cool question.
Oh, thank you for presenting so much interesting patterns. And I want to ask that because you mentioned the mixed initiated system, how will you use those observations to improve the human AI intent alignment? Yeah, because you know that the people's intents varied and as well as their patterns are varied. How will you do that?
Yeah, so I think the really interesting thing to me from that perspective is the intent elicitation stuff of like trying to ask questions proactively and generate maybe like little micro interactions or user interfaces that can kind of like probe the user to lightly put more of their own thoughts into the process, especially when it seems like they're disengaging or kind of like passing along more and more machine input as their own. The timing of that is going to be really tricky to get right, I think, because when it feels like it's interrupting you at the wrong moment, it feels really bad and jarring, actually. And we had an earlier version of Patchwork that was trying to proactively ask you questions to get more of you, like in the Patchwork world, basically. But it tended to overgenerate and it tended to interrupt when you were doing other stuff, at least subjectively. And so I think we need to figure out the timing stuff, which might actually be based on this linkography process to some extent. I also think the content of what to ask users for and the modality of like how to ask them for it are these additional sort of empirical questions that we just haven't really tried anything with yet. So I think those are both quite promising. I also think it's probably a good idea to move towards the machine generating sketchier or more half-finished or more visibly malformed outputs in some way. So that there's like this almost forcing function to like do more repair work or bring more of your own like thoughts into the gluing together of the machine outputs that are interesting. And we did some work on that in poetry with the system called Phraselet that you can read about if you want. Phraselet, the idea was we generated like lots and lots of different like sort of weird language expressions on this very short-term basis of like, it's up to 5 tokens or up to 5 words maybe. And by showing you like hundreds of 5-word sentences instead of like a handful of really well-written like prose passages, that seems to get users to like put more of their own thoughts into like sifting through and integrating and like making sense of those outputs. So I think that's another direction you could go.
Thank you.
Hi. I think it's thanks for a great talk. I think it's super interesting. You have so many cool visualizations of the creative activity traces, like Linkography, and I also like Shim's like Artographer paper. You mentioned like there's also other modalities that you're interested in exploring because they have also good embedding models like audio models, UI, and so on. I was wondering like how would you visualize maybe domains that are more temporal, like audio, that sort of stuff?
So this is like an open question to me, honestly. I think narrative is another big one where like if you look at long form stories, I got no idea how to embed those effectively. I think you could maybe do some kind of hierarchical thing where you look at like, oh, this is the first chunk and this is the second chunk and this is the third chunk. There are long text embeddings and you could maybe do like long audio embeddings too. But I don't know how much gets washed out by that. I think there's a lot of questions still to like figure out. Especially when working with the temporality aspect of like time-based media, there's just a lot of things where like treating it as these like relatively discrete little gems, like we have with poems, like we have with images, becomes more difficult. We're doing some work on a system that we call Elsewise, where we kind of try to look at play traces in video games, like sort of language model-based role-play games, as these temporally unfolding sequences of moments, and kind of visualize how those moments move from like one bin to the next in semantic space. So that might be an interesting one to check out. I think we're gonna have a preprint pretty soon, but. Yeah, like that one was still like a novel visualization problem that we're not sure we have the right solution to it yet. It's still pretty thorny.
Great, thanks.
So we are at time. Maybe if you have questions, like you can come on and have a chat with Max. But thanks again.
Awesome, thank you.